Every time you swipe your Metro card, use a washing machine, or wear a smartwatch, you're using an invisible technology that quietly runs the modern world. This is called an embedded system, a computer designed to perform specific tasks inside a larger machine or product. Let's look at three quick examples. First, an IoT temperature sensor that sends data from a greenhouse to a farmer's phone. Second, a motor controller inside an electric scooter that manages speed and braking. Third, a smartphone camera module with its own processor that captures and processes images before your phone even sees them. Embedded systems face unique constraints. Real-time performance. They must respond within strict time limits, like an airbag sensor that deploys instantly in a crash. Low power consumption, especially in battery-operated devices, such as medical implants. Cost efficiency. They must deliver their function at the lowest possible hardware and manufacturing cost. Reliability. Many operate for years without failure, such as in spacecraft or industrial controllers. A typical embedded system includes a CPU, the brain that processes instructions, memory to store programs and data, peripherals, sensors, actuators, or communication interfaces that connect to the outside world. For example, the microcontroller in a home thermostat has a CPU, a small amount of memory, and input-output ports for temperature sensors and display control. Embedded systems are the hidden heroes of modern technology, quietly enabling everything from smart homes to space exploration. If you're curious to dive deeper, our next lesson will explore a single peripheral, the GPIO, and see how an embedded system lets an embedded system interact with the real world.